Form of the equation, mostly graphable, reportable, very little. Anyway, so this equation is what we call the graphing form of a quadratic equation. You know what? Maybe we're not quite this far. Let me think. We might not even do 3-3 anyway, because 3-3 is easy anyway. So let me look. Yeah, we already did some of that stuff. Didn't we do 3-3? We didn't do paper 3-3? We might do a little bit of that then today and then 3. This is going to review that anyway. Maybe we'll just skip it and go 3-4. Okay, yeah, 3-4 is the most important anyway. Okay, here we go. So this is an equation. What do you think the H and K stand for? Does anybody know the equation of a circle? You guys learned that? You did some geometry last year. Do you guys remember the equation for a circle? Does anybody remember that? That's going to be the equation of a circle, right? Does everybody agree with that? You remember that from last year or no? You didn't learn the equation of a circle last year. Oh, this is actually pretty easy if you want to think about it. If y is 0, what's x going to be? 5 or what? Or negative 5. If x is 0, what's y going to be? 5 or what? Negative 5.
Oh yeah, because negative 5 times negative 5 is positive 24.
And if you think about this, this actually has to be, you would solve this for like y, right? And you'd end up with the square root of x squared minus 25, or no, 25 minus x squared. And you would put in values for x, and you could find values for y, like if you did 3 squared is 9, right? And then 25 minus 9 is? What's 25 minus 9? 25 minus 9. 16. Square root of 16 is? 4. So I would go over 3 and up what?
4.
And I'd be on that thing. I'd be on it right there. So this is 3, 4. Negative 3, 4. If I went negative 4, I'd go up what?
Negative
3. And positive 4, 3. And those are all points that are on that line, or on that circle. Okay, anyways, that's the equation of a circle. Well, guess what you could do? You could move this whole circle right and left. And the way you do that is you add or subtract a value to the x and the y. That's what we're doing up here. We're going to move the parabola right and left and up and down. What is moving then? What's the main bottom point or top point of a parabola called? The vertex. The vertex is what's shifting, and HK is the vertex. HK is the vertex. And that's what's moving around. What does the A value represent? We've already dealt with this. It's the stretch or shrink. We call this the scale factor that determines how much we stretch it vertically or how much we shrink it, smush it out vertically. Everybody with me on that? So that's how, this is the equation that we're going to be using today. If A is negative, what do you know? And these are some things you might want to write down. If A is negative, what would you know about this graph? If A is negative, how will the graph open? Down. Okay, if A is negative, the graph opens down. Now, if A is between 0 and 1, absolute value of A is between 0 and 1, the graph will do what? If it's like 1/25th or 1/9 or something, what will happen? It will be a vertical what? Shrink. It's going to widen up, right? If it's 1/9, 1/25th, things like that, right? Okay? If it's less than 1, if the absolute value of A is between 0 and 1, then it's going to be a vertical shrink. What if it's like 2 or 3? It's going to be a vertical what?
Stretch.
Stretch. You're going to go over 1 and up 3, over 1 and up 2, or whatever, right? Okay, so that's the scale factor part. We've already done that part. But this part we haven't dealt much with. And this is just a shifting of the graph. We have dealt with the k. We've already added to an x squared value, and what did that do? It moved it either up or what? Down. So the k value, this value, moves either up if positive, right there, that k value will go up if positive, or down if what? Negative. Okay, that's important to know. The weirdest part, though, is the h part. This is the opposite of what's in there, and it's because it's the value of x that would cause that inside to be 0. So it's the value of x that causes the inside to be 0. So if I have x minus 3 squared, let's just do this one. We'll just do this one with a t-chart so you can see it. Let's say we were doing this with a t-chart then. So let's do a little t-chart out here to the side. Let's go x and y. Let's go 0. What would 0 be? Plug it in.
9.
9, very good. What would 1 be? 4. I heard somebody say. What would 2 be? 1. What would 3 be? 0. What would 4 be? 1. And from there, you already know all the rest of them. How do I know the rest of them? It's symmetrical. So what's going to be 5, for example? 5 would be what?
4.
4. What's 6 going to be? 9. And you could go, and you could go from there, right? So let's graph this. Think about what's happening. 0, 9. Okay. And 1, 4. And 2, 1. 3, 0. 4, 1. 5, 4. 6, 9. Everybody agree with this? Where's the vertex? It's actually a positive 3, 0. How come it's 0? Well, there's nothing being what? Added or subtracted on the outside. Inside the parentheses, inside the parentheses, it's the value of x that would cause this to be 0 is how far it shifts right or left. It's opposite sign this way. But the reason I'm saying it that way is what happens if this is easy to say, hey, that shift is positive 3. What's this shift going to be? It's going to be negative 3 over 2. How did I get that? I set that inside of the equation equal to what? 0. Okay, this is going to shift the whole graph to negative 1.5. From negative 1.5, I could go over 1 and up 1. How come I went over 1 up 1? What's the a value? What's the a value? 1. It's the same as the regular graph. Remember, and I told you I would refer to this every day for the entire chapter. F of x equals x squared, or y equals x squared. What's the t-chart for this? 0, 0, 1, 1, negative 1, what? 1, 2, 4, negative 2, 4, 3, negative 3. So from this vertex point, I can go over 1 to the right and up 1. I can go left 1, up 1, right 2, left 2, up 4, up 4. So that's what I'm going to do. I'm going to go over 1, up 1, over 1, up 1. Now, see, really these are half points, by the way. This is over to negative 0.5. This is over to, I don't know, negative 2.5, right? But it's still up 1. Could I go over 3 from there? Or 2 from there, I mean. 1, 2. That's actually at 0.5, but it would still be up 4. 1, 2, 3, 4. Yeah, there we go. So this one's going to go like this, and obviously in this direction, same thing. Symmetrical. And this line right here is the line of symmetry, obviously. At what? What is this line of symmetry? X equals what? -3/2. That's why it's important to think of it as the value of x that would cause it to be what? 0. Don't think of it as just the opposite sign. You see what I mean? Now, yes, if it's an integer, it's just the opposite sign. It goes the opposite direction. But here it's going to go the opposite direction, but it's the value of x that would cause this to be 0. So think about that. You put in -3/2, what would it be? 0. Yes.
But that one is stretched.
Which one's stretched?
Two-
It will be stretched a little bit. We'll get to that later. But for now, I just want you to think about the vertex. It will be stretched as we square that out. So it will be. But for now, I just want you to worry about the vertex. Okay? I don't want you to worry about the stretch factor yet. We're just going to think about it moving. Because all we're doing is moving left and right. Because yes, that a value is going to change eventually. But we just want it to be this way for now. And then we'll get to that in a minute. That's what we'll do in about 2 more times we're going to do that actually. Okay, so let's look at another one. So where do you think this would be? Where would be your vertex point and how would it open? I want you to answer those 2 questions. Don't say it out loud, just think in your head. Where would the vertex point be and how would this open? What's your name?
Courtney.
Courtney, where do you think the vertex is?
Um,
I'm going to give you a hint.
it'll be down 4.
That's true. Where else?
Would it be to the right 3?
Actually, just opposite. It's going to go to the what?
Left.
Left 3. Think about the value that would cause this to be 0. So -3 plus 3 would be what? 0. So I'm going to go left, or -3, opposite the sign of what's in there, and then down 4.
Wait, what about the negative on that?
What about the negative in front? Yeah, what about that negative in front? It should open what? It should open down, right? Should it follow the same pattern though? -1, is it going to go over 1 and down like 2 or 3 or 4? No, it's going to go over 1 and down what? Over 1 and down what? 1. Over 2 and down 4. Over 3 and down 9. Because all that's happening, remember this is the a value, all these y values are getting times by -1. That's all that's happening. So as I go over from the vertex, not from over here anywhere, not from 0, 0, from the vertex, if I go to -2, I should go down to -5. If I go to -4, I should go down to -5. If I go to -1, I should go to 5, 6, 7, 8. I should go -1, 8. If I go to let's see, that's 2 away, this way, 5, I should go to -8. Now, so my guess, this is what I'm saying, now we'll see if I'm right. Maybe I'm wrong, maybe I'm up in the night, maybe I don't know what I'm doing. Maybe I'm asleep. Maybe you're asleep. Hopefully not. Oh wait, this is -5, my bad. Okay, and this is -3, -4. This is -2, -4, 5. And this is -1. -1, 8. -8, sorry. -8. Okay. Do you think I'm right or am I wrong? How could you tell if I'm right or wrong, by the way? I mean, I'm saying that's the graph. How could I tell if I'm right or wrong? You can make a T what? A T chart. Let's do that just for this, and we're not going to do this very often, but let's do it. Let's just pick some x and y values. What x values do I want to try? The ones that are on my chart. See if it's right, right? Okay, let's put in -3. Leave it in this form and it actually makes it easier. What's -3 plus 3? 0 squared is 0, so -4. So that one's right, for sure. Okay? Let's try negative 2. What's negative 2 plus 3? Now this is important. Negative 2 plus 3 is 1. 1 squared is 1, but there's a negative in front, so I got to make it what? Negative. So this is a negative 1 minus 4 is negative 5 when I put in negative 2. That's good. How about negative 4? What's a negative 4 plus 3? Negative 1, but I'm going to square it. It's going to make it positive 1, but then I got to make it what? Negative, so I'm going to end up with a negative 1 minus 4. That's going to be negative 5. Let's try negative 5, just to show you. So negative 5 plus 3 is what? Negative 2 squared with a negative in front. Negative 2 squared is 4 with the negative in front makes that negative 4 minus 4. And I end up at negative what? 8. And then same thing's going to happen at negative 1. Because it's symmetrical, right? So that worked out nicely. That's kind of cool, huh? And that's how it works. That's how easy this is, if you can get it into this form. Okay? This represents the opposite direction, right? Because it's the value of x that would cause it to be 0. This represents the up and down. Okay? This represents the scale factor. One last one, just to make sure you got it. This is the last part you're going to record. Okay, so we're going to have y equals, everybody try this on your graph paper and see if you can do it. Y equals 1/2 x minus 2 squared minus 5. Everybody try that. I'll give you about 2 minutes. See if you can do it. Then I'll do it. I can do it in about 10 seconds. But let's see if you can. How many of you have marked your vertex already? Good, you should have. You should already have your vertex marked. The trick is the scale factor actually, which is the first thing we learned. But using that scale factor, you should be able to put in symmetrical points from the vertex. Using the parent graph idea, just shift it, right? Just shifting the parent graph. Should be able to put 2 points to the right, 2 points to the left, and then call it good. I wouldn't use 1 as a point to the right. I would use, say, 2 and 4. Right here. I'd use 2 and 4. And I would times them by not -1, but 1/2. And I would go from the vertex that is shifted from there. Hopefully that helps you think through what you should be doing on your graph. Okay, let's see if you graphed what I graphed. How many of you have that point? How come I went positive when it said -2? That's the value that would cause it to be 0. It's the opposite direction, right? So I went to +2, and then I went down what? 5. Did everybody have that vertex point? If you didn't, can you see why you're wrong? Okay, that's the important part, not whether you're wrong or not, just can you see why you're wrong? Okay, now, from there, the way I graph these is probably different than the book would have you do. The book probably has you put in some points and do a T-chart. I don't do that. I go to the right 2 from the vertex, and then I'm going to go 1/2 of 4. 1/2 of 4 is 2. So this point right here is actually 4, -3. It's to the right 2 and up 2. Same thing to the left. Left 2 and up 2. This is 0, -3. Okay? And then, that might not be quite straight across, but that's close. There we go. All right. Then where should I go? Well, instead of 16, what's 1/2 of 16? 1/2 of 16. 8. I'm going to go right 4 from 2, though. From here. 1, 2, 3, 4. I'm really at 6 now. And I'm going to go up 8. Well, I'm at -5 at the bottom, right? So there's 5, 6, 7, 8. Where did the 8 come from? half of what? 16. So this is 6. And I'm up 8 from negative 5. This is actually 6, 3. Are you with me on that? But I thought I went up 8. Did I go up 8? Yes. From the what, though? Vertex. You don't start at 0, 0 and go up 8. You start at the vertex. You go over 4 and up half of 16, which is 8. Same thing to the left. I'm at 2. I'm going to go over 4. That puts me at negative 2. And then I'm up here at 3. So I'm at negative 2, 3. Those are values that would be on this graph. And that's how I would graph it. How many of you had a graph that looked just like that? Raise your hand if you did, before I even graphed it. How many of you can see how I graphed it and you say, I think I can do this? Okay, let's see if you can. Last one. You can stop recording.